Everybody. I just wanted to follow up on the example I posted on LinkedIn the other day of our agent framework that we're working on, and just kind of run through all of the code in the conversational memory example in our macro expand 2 demo repo. We are here in our handy dandy closure REPL. Code on the left, REPL output on the right. When I evaluate code on the left, we'll see some results on the right when there are any relevant results to show. So, as I mentioned in my post, our agents are event sourced, and their long-term memory is a projection or snapshot of the events in the event store, in the domain. And in order to actually append events to our event store in Grain, you have to actually define schemas for them, because the event store validates those schemas on the way in. And so if any events are missing a schema, or the data is invalid against the schema, then it gives the event store an opportunity to throw an error and reject those events. And so what we're doing here, def schemas, event schemas, Grain has a kind of central registry for schemas, and so anywhere in your code in your project you can use this def schemas macro to kind of register back to that central registry. And what we're doing here is we're saying, okay, we kind of have like a agent domain, so to speak, for a chatbot, and we're saying that the two events that exist in this domain are message received, and it contains a key of message with the value of a string. That's the user's message that they send to the agent. And then reply sent, which also just has a message key and a string value. And that's to represent when the agent has responded to the user. The next thing we have is more schema definitions, but this time it's the sort of domain of the agent. It's the language that, if there were multiple sort of a more complex behavior tree and multiple LLM interactions through DSPy and whatnot, being able to unify the domain schemas in this way allows the entire pipeline and workflow to speak the same language. And that way, if you need to change something about what language they're speaking to each other, you can just change it in one place. You don't have to start your workflow like this. You can actually start by just defining your schemas inline in your def signature calls, but it helps once you have multiple interactions that are all sort of like duplicating the same schema. Then you're like, oh, okay, this is an important concept. Let me start consolidating this in a central place. And so one thing that Grain allows you to do is unify your schema across both your Clojure orchestration layer and your actual Python execution layer, at least with respect to DSPy. And so the double colon here, for anyone not aware or new to Clojure, it's just an auto namespacing capability, and so it creates a one unique value for the namespace that I'm currently in, which is ai.obni, O2 conversational memory, and then /conversation. And that just makes it to where we can add items to the schema registry without overlapping or overwriting other values. So that's all the double colon is doing there. So we have a conversation. We're saying it's a vector of maps where you have a role key and a content key, and both are strings, and that should look familiar to anyone who's been playing around in the space. When we supply like conversation history or messages to especially like an OpenAI compatible API, what we typically see is a list of messages where the role is either like user or assistant, and then the content is the message itself. We have some descriptive text here, conversation history. This is not just documentation. This schema will be used to create a DSPy signature with Pydantic base models, and this descriptive text actually makes its way onto those and so it makes its way all the way to the LLM. So it's able to see the descriptive text for and know that this is conversation history or whatever else you might want to tell it. Then we have the question. This is more of a short-term memory thing. The user's question gets added to the short-term memory, and it has this shape, but it also gets sent to the LLM as well. So you have descriptive text, the user's question, and then we have our answer that comes back as the output from the LLM, and what ultimately gets ferried back over to the user's chat client or whatever. So we have more schema definitions there. Next, we have a DSPy signature that we're going to define called chat. So this def signature call is actually part of our package called CLJ DSPy. And what it does is it allows the user to declare DSPy signatures, their inputs and outputs, and also the shape of the inputs and outputs using a subset of Mali, which is the schema language and library that's being used here. So we didn't invent our own schema language. We're using like a well-known and robust schema language from the Mali library closure. And so in that way, we are taking this doc string here for the macro call. That becomes the doc string on the DSPy signature class. And that ultimately becomes the main instruction for the LLM. And then we are able to say, okay, and you also have a conversation, a question, and an answer, and these are the shapes, and those become more detail for the LLM as well because of the way that DSPy makes use of pydantic base models, descriptive text, and typing. And so what this is really doing is it's taking care of all of the structured inputs and outputs that you want to take care of without actually having to define any of that yourself. And on the back side of things, this macro essentially generates some Python. It generates an input pydantic base model, an output base model, and then a DSPy signature that uses both of those. And that allows the DSPy portion of the workflow and pipelines to do automatic validation and data marshaling as you go from model call to model call. Another interesting detail is that there is some magic that happens with our behavior tree node for DSPy. These inputs and outputs on the left side here, the keys, so conversation, question, and answer, those are actually implicitly referencing the agent's short-term working memory while it's running. And so there's some automatic validation that assumes that those conversation, question, and answer are going to be there. And this def signature call generates some metadata that is used at runtime to do all of the marshaling from the DSPy Python calls into closure data types into the short-term memory so that the rest of the behavior tree can operate on it. And then also to feed inputs and outputs into and between more calls to def signatures with DSPy. Then we have a function that's going to maintain our conversation. So after the agent has responded and produced an answer, we run maintain conversation. And you can see here that we're just accessing the question and answer from the agent's short-term memory. If you're unfamiliar, this @ sign is just a shorthand for dereference. Short-term memory is a closure atom, and so you have to dereference it to actually see the current value. And so we used Grain's event store to append some events. We append the message received, and we append the reply sent from the agent. Then, of course, this is what I posted on LinkedIn the other day, the behavior tree. So it just has a basic sequence, and a sequence node in a behavior tree expects all the children to return success. And so if they don't, then there's either a failure or the behavior tree is still running. In this case, it's a one-shot thing, so it'll always return success unless something goes wrong, and then it will return failure. So any of these conditions, like this one checking for the question in short-term memory, this one saying, hey, there might be a conversation history in the long-term memory, and if there is, make sure it looks like conversation, the schema up above. Either of these could fail, and that would say, well, we're not even going to proceed with the rest. We'll just return failure because these conditions didn't pass. And so you can kind of think of those as preparing to do the actual chat interaction with the LLM. And in here we're saying, okay, we're going to use the reusable behavior tree node in Grain's DSPy extensions, and it takes an argument map here. You give an ID to the actual action, because what you can't really see here is that every DSPy action that occurs through predict or chain of thought or whatever is actually emitted to the event store, so that you can actually go back and see every single step, inputs, outputs, reasoning chain, etc., that the agent has done while executing a workflow. And the ID just keeps things unique and prevents them from sort of overlapping, and allows you to know what you're looking at, so that you can go back and debug if you need to. Then we have a final condition. After the answer is produced, it should actually be there, and it should be a string. And we're checking the short-term memory for that. Then we run the action. We know we're good to run maintain conversation at that point. And so how is the projection of the conversation history actually done? Well, the behavior tree, whenever you're using long-term memory, which is optional, by the way, you need to supply a read model function or a projection function, whatever you want to call it. Basically something that can take in certain types of events and then build what this is saying it should look like. So a vector of maps where each item in the vector, each map in the vector has a role and a content key. And so that's what this read model function does. It just says, like, hey, if you see either one of these events come through while you're processing, while you're building the projection, just update the conversation, which should be a vector. And when we go to update it, if it's message received, just show that it's from the user, or if it's not, then that means it's a reply sent, and so it's from the assistant. And so that builds our conversational memory. And then we can see how we actually initiate all of this. We create an in-memory event store. We also have a Postgres implementation. It's just a one-line change to swap out the type and some connection details, but it's the uniform API across whatever backend you're using. We actually go to build the behavior tree, and so we supply the behavior tree from up above. We supply the event store, we supply the read model function, and we say, hey, we're interested in these event types, message received and reply sent. And then we just set up a context, which is going to be used for the textual terminal app that we're about to see here. And this is actually done via Python interop with the textual 2E terminal UI framework. And so we can say, hello, how's it going? We get our response back. I can say, I'm good, thanks. And then I can ask, what is the first thing I said to you? And it tells us, hello, how's it going? And I can ask, okay, what is the second? I'm good, thanks. And so that's just a demonstration of our conversational memory. If we take a look at all of the events in the event store, and there's a lot of data here, but it's interesting, we can see that all of the node ID, where chat is the node ID, is the chat interaction actually happening, and we can see when it happened. We can see that chain of thought was used because the Grain agent reasoned. We can see the inputs, the outputs, and the reasoning that it used. And this can all be used to build and facilitate more complex interactions and auditing use cases. Then we can see the actual events being stored for maintained conversation, the message received and the reply sent. There are some metadata, like meta-level transactions that Grain does that just keeps track of what events were stored together at the same time. But we can see the more the subsequent calls to agent reasoned. And you can actually see here, at this point, the conversation history. So we have conversation being passed in as input. The user said, hello, how's it going? Hi, I'm doing great, how about you? And if we go to the last interaction, where the user's asking, okay, what was the second? We can see the full conversation history here. And then we can see the reasoning chain. The user is asking me to recall the second thing they said to me in our conversation. I can find this in the conversation history, and of course, it is actually there. And so that's just a brief overview of this example. There's a lot more to be said, and there's also like a much more complex behavior tree in the third demo that I'll cover maybe at some point. It includes like a generic tool use subtree. So yeah, thanks for listening.